Hi and welcome to MSc. In this video we're going to be looking at the cast rule. Now the cast rule is a rule that tells us about the sign of the trigonometric ratios in the different quadrants. Let's look at the angles in standard position that form here. So we have an angle here, and we know in quad 1 that the theta, the angle in standard position, is actually also equal to the reference angle phi. And we also can see that we can create a right triangle here. And this right triangle will have a base along here of 8, a height of 5, and if we use the Pythagorean theorem, we can show that it has a hypotenuse of 89. Now we know that sine theta is equal to opposite over hypotenuse. We know that cosine of theta is adjacent over hypotenuse. And we know that tan theta is equal to opposite over adjacent. Excellent. So if we look at this triangle and we're defining the angle in this inner corner here, our opposite side will be the y value of the terminal point here, and our base will be, our adjacent side will be the x. This hypotenuse, which is 89, it will be equal to r, the radius of the arm that would go all the way around. So I can rewrite these saying that my opposite side will be y, my hypotenuse is r, my adjacent side of that angle is x, my hypotenuse is r, and here it's going to be y over x. Well, notice here in quadrant 1 that none of these values are negative, right? We're in the positive x-axis, positive y-axis. R is from Pythagorean theorem. It's always going to be positive in this case. And so it looks to me like all will be positive in this case up here, sine, cosine, and tangent. Let's see how that translates into the other quadrants. Here in quadrant 2, this is my theta value, and I have a reference angle phi. There is a relationship between phi and theta that we're starting to build and starting to be able to see, I hope, and I'll do more of that in a later video as well, comparing theta and phi. If we look at this right triangle that we can form here, I again have x and y values. My y value here is positive 9. My x value, it's negative 5. So even though we created a triangle, it's on the Cartesian plane. So the coordinate up here will be negative 5, 9. Based on this, we can show that the r value is the square root of 106. And that's my r value. All for this terminal point of negative 5, 9. So based on this, if we look, which one has x in it? Well, x cosine does. It has the adjacent side, which is x, negative 5, and tangent has x, negative 5. So it appears in this quadrant here, the second quadrant, it appears as though only sine is going to be positive here. So it looks like here we'd have sine theta being positive. And you might look and say, well, we did that with respect to phi, but there is a relationship between phi and theta. So in the second quadrant, based on what we're seeing here, sine will be positive. If we go around to the third quadrant and try to repeat, we have our angle in standard position. We have our reference angle, phi, and we can create another right triangle here. There's the right triangle, and again we can start labeling our sides. Well, this looks like it's to this terminal point. This will be x equals negative 9. Here it looks like y is equal to negative 6, and again using Pythagorean theorem on this, you get r is equal to the square root of 117. Well, we can see that both x and y are negative, so sine will be negative, cosine will be negative, and tangent will have a negative over a negative. But a negative over a negative is a positive. So in quadrant 3 here, tan theta will be positive. So we started in quadrant 1 with all of them being positive. Then in the second quadrant, sine is positive. In the third quadrant, tangent's positive. The only one that hasn't been positive yet is cosine. So here's my angle in standard position for this fourth quadrant. I have my phi value, which is this angle here. That's my phi. We can draw a right triangle. And this gives me a y value here of -3 to this terminal point, whereas this gives me an x of 7. In this case, it can be shown that the r value, the hypotenuse, will be the square root of 58. Feel free to double check these r values. In this case, you'll notice, just like the others, r is always positive. My x is positive. It's my y value. It's my opposite side that's negative. So that will drive tangent and sine to be negative and will result in a positive value for cosine. So we have cosine that will be positive. This is what's called the cast rule. And we can see here that here we say C in this quadrant, we say A in this quadrant, we say S for sine in this quadrant, and T for tangent in this quadrant, making up the cast rule, C-A-S-T. Another mnemonic device that's sometimes used is we say all students take calculus. The reason why that's often used is because the all there in that starts with the first quadrant, whereas the cast rule, the C in the cast rule, starts in quadrant 4. And sometimes that's tricky to have an acronym that doesn't start in the first quadrant. The relationship between phi and theta we'll have to explore a little bit more in a subsequent video. But this is the driving reason behind the cast rule and understanding why we have different trigonometric functions being positive for angles in the different quadrants. I hope this run through of the cast rule has been helpful. If it has, please consider liking the video and subscribing to the station. And as always, thank you very much for listening and watching.